Okay. Again, welcome you all to this optional course which is conducted by CDEP, software-based data analysis using STATA and Minitab tools. So I have already updated the LMS with the venues and what's the course module. And have you all enrolled for this lecture in LMS? Were you able to enroll this lecture on LMS?
Yes, madam.
Okay. Then I'll upload the course specification on that itself so that you all can have a look on the course specification. What are the things which we are going to learn? That means the content and everything, and the books which we are going to refer, and with the practical assessments, everything I'll be communicate through this entire course through this LMS. So if you have any questions, you can open kind of few student forums or else questioning Q&A sessions on the LMS as well under the relevant week itself, so that we all can um, answer. I also can provide answers for those questions, and also your colleagues also can answer your questions itself. So that's about it. So let's move to the lecture. Today, we are going to start the lecture software based data analysis using STATA and Minitab. As I can remember, most of you were preferred to conduct this entire lecture in English, but don't, I mean, that's totally fine. If there's any kind of language issue or something like that, please interrupt me at any time so that ask questions from me so that I can help you. Otherwise, I also don't know what's happening here. Okay. Okay. So if we move to the next slide, what is statistic? What do you think about statistics? What are the things you think? What are the things you know about statistics? And what is statistics? Any idea? How can I hide this one? Okay. What do you think? So when it comes to statistics, actually, here I have already provided a current actually kind of a good content in these slides itself, so that you can read by yourself, and also you can listen to these entire recordings as well, and then you can learn these ones by yourself as well. Okay, so let's go through with the statistics. So what is statistics actually? So when it comes to statistics, the art and the science of answering questions and exploring ideas through the process of gathering data, describing data, and making generalizations about a population on the basis of a smaller sample. What does that mean? If we so let's consider this one as kind of a definition, and let's split these ones into smaller parts. A statistic, the art and science of answering questions. Okay, by using these statistics we are going to provide answers for some questions, and also we are going to explore some ideas through the processes of gathering data. Are now in statistic, we have to gather data and we have to describe the gathered data, and then we have to do kind of generalizations for all these collected data and also the described data about the population on the basis of a smaller sample. Now, there are two different phrases. One is a population and the other one is the sample. There might be people who have already known about these terms and everything, but that's fine. That's totally fine. So make it like a revision of those, a revision of your. This is kind of a, let's consider Like this is a place where to rebuild or memorize your previous memory or previous knowledge as well. So there are two terms. One is a population and the other one is the sample. What are the differences of these two? Why we are using these two? What is population and what is sample? It's better if you all can talk. That's totally fine about the language. Just talk with me so that I can, so I can't see your faces, no. So then that means actually I can't get a live feedback from you. So it's better if you can talk with me, if you can provide answers to me, so that it this might be like two-way communication, so that I also can understand whether you were able to understand or not. So what are the differences of this population and sample? Give some example for the population and for the sample. Okay, let's assume that we are going to do a research. We are going to conduct a survey on whom about the university students. Okay, let's assume that we are going to conduct a survey or research about drug addiction among university students in Sri Lanka. So what would be the population and what would be the sample? So when it comes to population, so w- what was our experiment? Our experiment was to, we are planning to do a research on all undergraduate students, university students in Sri Lanka about the drug addiction. So then our population is the all university students. But maybe sometimes if we are trying to access the entire population, if we are trying to gather data from the entire population, so it might be like very costly. So that so so that what we do here is we just take a sample of the university students. Let's assume that University of Colombo and University of Sri Jayawardenepura, our university, and also University of Moratuwa Kerala. We just selected students of those two universities and then make a sample. So our population is the entire university students and our sample is the students we selected from University USJP and UOC and also UOM. Is that clear, guys? So the difference of the population and difference of the sample. Is it clear? So no comments. Okay. At least type on the chat as well whether it's clear or not, so that if you can't talk or if you are not willing to talk, then at least I
It's
can.
clear, madam.
Okay, then what will happen here? Uh, if we move to the statistical literacy, so here I have provide an definition, that is people's ability to interpret, describe, interpret and critically evaluate statistical information and data-based arguments appearing in diverse media channels and their ability to discuss their opinions regarding such statistical information. So this is kind of another definition which we can use for the statistical literacy. And here, where I took this statement, I have mentioned that one as well here. And then the statistical literacy is important because you are faced with statistics problems in your personal and professional lives. For example, anyway, so there are so many problems, there are so many issues which we can provide answers by using these statistical analysis, or else we can provide solutions statistically by using these statistics, so we can solve those problems day to day. So these economic problems also, what we do, we just analyze the previous entire data, and then forecast or predict for the next year, or else in future patterns, or else future happenings. That is it. So then what we have to, like, answer. So then examples. Here I have mentioned few examples where which we use statistics in day-to-day life. So choosing a medication. Your doctor gives you the option to choose one of two different medications. She provides you with research studies comparing the two medications. How can you use those research studies to inform your decisions? What do you think? So, for example, let's assume that if you have to choose kind of a um, medication from another two options or something like that, two different options, two different medications, then anyway, so what you have to do, you have to analyze the previous research studies, uh, and also the information they have provided, and then what you have to do, you have to get your decision. And for the football matches, fantasy football matches also, in planning for your fantasy football team, you come across many tables of statistics. So how can you synthesize all of those numbers to best inform your fantasy football draft? So right, so these are kind of few areas which we use statistics in our day-to-day life. So school curriculums, driving to work, and marketing decisions. These are kind of very few examples, or else very few areas which we are using statistics in our day-to-day life. So foundation, population and parameters. So okay. So here now we know what are the differences of these population and also the parameters as well. So sorry, population and also the statistics. Sorry, population and also the sample. So populations and the parameters means the terms which we define these population. Let's assume that the terms which we define, or some numerical values which we define, which we identify this population, we call them as parameters. Okay. So if some terms which describe the samples, we call them as statistics. Okay. So that means statistics. That means anyway, we have two different what? We have uh, two different things actually. That is, two different means this is not exactly different. So population is the entire complete thing, and sample is kind of a subset. So for the populations, we generally produce, or we generally explain these populations by using these parameters. But for the samples, we have to define statistics. That is the main difference. So here what will happen for the populations and parameters? For the population mean, here I have mentioned a definition: any large collection of objects or individuals, such as Americans, students, or trees, about which informed is desired. Which information is desired? The entire collection of objects, that is population. So for this other part, then Parameter means actually any summary number like an average or percentage that describes the entire population. We call them as parameters. Is it clear so far? For the parameters means the summary numbers or as the numerical numbers. For example, we can say average, percentage. Those are kind of few examples for these parameters that describes the entire population. Okay. Okay. Then let's move to the next part. So now we have to know about the what how we denote these ones here also we have to know. No? So then population means if it is a population, then for the population mean we denote it as mu. Okay, we denote the population mean as mu. And the population proportion is like capital P. These are the two parameters. These are the two symbols of parameters. So the two parameters are population mean as well as the population proportion. One is population mean, the other one is population proportion. So how can we denote this population mean? That is mu. For the population proportion, that is capital P. Are two different population parameters. Now let's see what is mu and what is P. What do you think? We might be interested in learning about the average weight of all middle-aged female Americans. So the population consists of all middle-aged female Americans and the parameters is mu. That is it. So the entire population, from the entire population, we derive the mean. Okay. Then we can call it as the population parameter, which is mean. Or we might be interested in learning about the proportion. Earlier, we just interested about the averages. But here we are going to talk about the proportions. We might interested in learning about the proportion of likely American vectors approving of the president's job performance. So the population comprises all likely American voters and the parameter is P. That is about the population proportion. Is it clear? If we move to the next point, the problem is that almost all of the time we don't or we can't know the real value of a population parameter. I also raised that problem earlier as well. So the best thing which we can do is we have to estimate those parameters. So we can't get the actual values for those population parameters. So what we can do just we can estimate all the parameters. This is where samples and statistics come into a play. Is it clear up to this point? Any questions so far? Okay, so let's move to the next part. Okay, so now here I have the samples as well as the So here what will happen? The samples and the statistics. So here the sample means okay, we have already discussed these ones, no? So the sample is a kind of a subset or else a representative. So it is kind of a subset or else um, it is kind of a subset or else a representative, a group, representative group drawn from the population. And for this statistic, any summary number like an average or percentage that describe the sample, we call them as what? The statistics. That is it. Now let's go through with the notations. The sample mean X bar. Okay, so the sample means, earlier we just talked about the population mean. For the population mean, we had mu, but here for the sample mean, we have X bar. And the sample proportion we have simple P hat. Here for this X bar also, we generally use the simple values. For the sample mean, we denote it by using the simple X bar. And for the sample proportion, that is P hat, simple P hat, are two different sample statistics. For example, we might use X bar, the average weight of a random sample of 100 middle-aged female Americans, to estimate mu. That is the population mean. No? So the average weight of all middle-aged female Americans, if we estimate that population from a sample, we call it as an X bar. So here, this is kind of an example for the sample mean. And then for the sample proportion, we might use simple P hat, that is for the sample proportion. The proportion in a random sample, you might don't know about these random samples and everything. We'll discuss these ones later. So just take an idea about the sample mean and the proportion. So for the sample proportion, what do we have? Here, we might use P hat, the proportion in a random sample of 1,000 likely American voters who approve of the president's job performance. To estimate population proportion, the proportion of all likely American voters who approve of the president's job performance. And that is it. Because samples are manageable in size, we can determine the actual value of any statistic. We use the known value of the sample statistic to learn about the unknown value of the population parameter. That's it. Okay. So if we move to the next parts, then techniques of describing data in ways to capture the essence of the information in the data are called descriptive statistics. For example, the sample mean is a descriptive statistic. To draw conclusions from the data about the population is called inferential statistics. So, there are two different statistics. What is the descriptive statistic as well as the inferential statistics. Generally, if it is descriptive statistics, that is technically descriptive statistics are describing all these data by using the charts or any kind of things, mean, median, mode, from these ones. But for the inferential statistics, here that means we draw kind of few conclusions from data about the population That is called inferential statistics. Here is a picture that demonstrates inferential statistics. Let's move to the next slide. Here, you can see kind of a entire picture of the entire uh, picture of the entire picture of the scenario. Okay, any questions? Any questions? Okay, so let's move to the next part, that is introduction to Minitab. So today I'm not going to do kind of practicals. So from next day onwards, you all have to do the practicals within the labs. So, okay, introduction to Minitab. But okay. So I'll skip this part for today because since you don't have the softwares with you right now and we are not doing these practical, so I'll skip these slides and then I'll go through with these Minitab slides next day when we are doing the lectures physically. So here again we have the analyzing data part, Minitab help and everything. Okay. That is kind of a brief introduction about the Minitab. So the lesson 1, collecting and summarizing data. So I hope you all can remember that Damayanti madam was said. So these entire steps are really needful to do your researchers as well. Researchers as well. So here, lesson 1, we are going to talk about the collecting and summarizing data. Overview. So the lesson start with a discussion about how to collect data and the different methods to use. So once the data is collected, we need to summarize the data. How to summarize the data depends on which variable type we have. All of these concepts will be presented here within this lesson 1, collecting and summarizing data. So for these objectives, here I have mentioned the objectives of this entire lesson, first lesson as well. You can go through with these objectives by yourselves alone. Okay, now let's move to the collecting data. So what you all know about this collecting data? So for the collecting data is an important first step in statistical analysis. So while you are doing the researchers as well, then what you all have to do first, if it is kind of a quantitative research, anyway, it's based on data. So that you have to collect data. So the goal of statistics is to make inferences about a population based on sample. So here what will happen? so as I told you, when it comes to collecting data, so the collecting data is an important first step in statistical analysis. So the goal of statistics is to make inferences about a population based on a sample. How we collect the data is important. So if the sample is not representative of the whole population, we cannot make inferences about the population from that sample. So for example, let's assume that the entire population, there is kind of a female and male percentage as so female percentage is 70% and for the male percentage 30%. So this is the population එකේ තියෙන percentage එක, female and male. So for your sample also, the derived sample also, you have to, the best way is if you have the proportion like for the female 70% and for the male 30%. So it should be follow all the what should I say? It should be exactly same as the population because it should be kind of subset of the entire population. So if the sample is not representative, if let's assume that the derived sample, maybe sometimes the female percentage goes 30 and male percentage is 70, then what would happen? The entire inferences we made from these samples for this population is incorrect. So generally, it should be same as the population. So the following are few frequently used methods for, give me 1 minute. So someone is calling, give me 1 minute, guys. So here, the following are few frequently used method for collecting data. Personal interviews are there, telephone interviews are there, self-administered questionnaires are there, direct observations are there, and also we have the web-based surveys as well. These are kind of few methods which we are using to collect data, which we use to collect data. Okay? Okay. Types of bias. So maybe sometimes the collected data, it might be sometimes biased. So there are three types of biasness. One is non-response bias. The other one is response bias. The third one is the selection bias. So when it comes to non-response bias, when a large percentage of those sampled do not respond or participate, සමහරක් වෙලාවට here what will happen? Uh, though we give kind of a questionnaire. 1 minute, guys. Hello, Oğuzhan da bağlı mıyız? Oh. Sorry, students. So here for the non-response bias means actually when a large percentage of those sampled do not respond. So for example, in our university level also, we might sometimes experience those kind of things because though we give questionnaires, students are not filling those questionnaires and then give back to us. So then if it is like that, it means the non-response biasness is high. So response bias means when study participants either do not respond truthfully or give answers they feel the researcher wants to hear. For example, when students are asked if they ever cheated on an exam, even those who have would respond with no. So, for example, sometimes if they have responded one reason many times, again, it might be kind of biasness for that answer. And also for the selection would be the last type of bias. That is, this bias occurs when the sample selected does not reflect the population of interest. That is an example for the previous one, that the 70% example. So in the population, we have the percentage, female percentage as 70, and for the male percentage as 30. So maybe sometimes our selected sample doesn't follow that proportion, or else the proportion. So that means that is not, the derived sample is not reflect the population of interest. So for instance, you are interested in the attitude of female students regarding campus safety, but when sampling, you also include males as well. In this case, your population of interest was female students. However, your sample may included subjects not in that population, that is males as well. These are kind of few examples which we can provide for these types of biasness. Strategies for collecting data. Now what we have to follow, these are kind of few strategies which we have to follow when or while we were doing, we were collecting data. How can we get data? How do we select observations or measurements for a study? There are two types of methods for collecting data, non-probability methods and probability methods as well. There are two types of methods of collecting data. So one is non-probability method and the other one is the probability method. So if we go through with this non-probability methods, in this non-probability method, there are two types of methods. That is, one is convenience sampling, the other one is gathering volunteers. First one is the convenience sampling and the second one is the gathering volunteers. So for the convenience sampling, what will happen? Collecting data from subjects who are conveniently obtained. For example, surveying students as they pass by in the university student union building. But for the gathering volunteers, that means collecting data from subjects who volunteer to provide data. අපිට ඕනේ අයම නෙමේ voluntarily answers provide කරන්න කැමති set එකකින් what we do, we just collect data. හරිද? කලින් එකේ convenience sampling කියලා කොහම ඒගොල්ලෝ තමයි sampling වලට කොහොමත් එන්න ඕනේ. පහසු අයගෙන් තමයි අපි ගන්න. එතන ඒගොල්ලෝ කැමතිද නැද්ද නෙමෙයි, අපිට access කරන්න පහසු අයගෙන් තමයි අපි ගොඩක් වෙලාවට ගන්න. But for the gathering data, what will happen here? අපි gathering data වලදී කරන්නේ voluntarily fill කරන්න කැමති, අපිට answers provide කරන්න කැමති අයගෙන් විතරයි අපි data collect කරන්නේ. For example, using an advertisement in a magazine or on a website, inviting people to complete a form or participate in a study. Okay, that's it. So probability methods. Let's move to the probability methods. So earlier we discussed about the non-probability methods. So these are two examples for the non-probability methods. Now, if we go through with these probability methods, what will happen? There are kind of few methods, probability methods. One is simple random sample. Another one is stratified random sample. The third one is clustered sample. If I go through with these three one by one in brief, so for the simple random sample means like making selection from a population where each subject in the population has an equal chance of being selected. අපේ population එකෙන් sample එකක් derive කරනවා නම් එහෙම නැත්නම් sample එකක් ගන්නවා නම් අර population එකේ තිබ්බ හැම item එකකටම මොකක් වෙනවද? population එකේ තිබ්බ හැම item එකක්ම අපේ sample එකට තෝරන්න තියපු සම්භාවිතාවය සමානයි. එහෙම වෙලාවක අපි කියනවා we called it as simple random sample. But for the stratified random sample means actually where you have first identified the population of interest. You then divide this population into strata or small groups based on some characteristics. For example, maybe sometimes sex, sometimes geographic regions, මේ කියන්නේ provinces, එහෙම නැත්නම් regional මොනවාද divisional secretaries or something, any kind of factors, any kind of characteristics, we are going to make few groups or stratas and then perform the simple random sample from each strata. ඉස්සෙල්ලාම අපි මොන හරි characteristics identify කරගෙන ඒ characteristics වලට අනුව අර stratas එහෙම නැත්නම් small groups අපි කඩා ගන්නවා. ඊට පස්සේ groups වලින් තමයි simple random sample වලින් අපි අදාළ performance ඔක්කොම කරන්නේ. And for the third one, we have a last one called cluster sample. For this cluster sample, there what we have is where a random cluster of subjects is taken from the population of interest. For instance, if we were to estimate the average salary or for faculty members at Penn State University Park campus, we could take a simple random sample of departments and then find the salary of each faculty member within the sample department. අපි cluster sample එකේදී මොකද කරන්නේ? ඉස්සෙල්ලාම අපේ campus එකේ එහෙම collect කරගන්න ඕන නම් අපි ඉස්සෙල්ලාම කරන්නේ department wise separately පොඩි clusters අරගෙන ඒගොල්ලොන්ගේ ඒවා collect කරගන්නවා. ඊට පස්සේ ඒවා one by one collect කරගද්දී generally entire university එකේම ඒවා අපිට collect කරගෙන තියෙන්නේ. Okay, we could take a simple random sample of departments. අපි simple random sample කියන්නේ දැන් හිතන්නකෝ අපේ campus එකේ නම් departments කීයක් තියෙනවද? අපේ faculty එකේ නම් departments 15ක් විතර තියෙනවනේ. එතකොට අපේ department එකේ faculty members ලාගේ salaries අපිට check කරන්න ඕන නම් අපි departments වලින් එකක් simple random sampling method එකකින් අපි එක department එකක් select කරගෙන ඒකේ ඇතුලේ ඉන්න ඔක්කොම faculty members ලාගේ salaries analyze කරනවා. Those are the three sampling methods, probability methods. Is it clear? Can anyone respond me through the chat or else through the chat, via the chat, or else can someone give me kind of a feedback? Is it clear up to this point? Okay, someone is. Okay, thank you. So here what will happen, there are advantages and disadvantages to both types of methods as well. For the non-probability methods as well as the probability sampling methods as well. So here I have mentioned all the disadvantages and a kind of few disadvantages as well as the advantages of those two. You can go through with these. Non-probability methods are often easier and cheaper to facilitate. When non-probability methods are used, it is often the case that the sample is not representative of the population. If it is not representative, then you can make generalizations only about the sample, not the population as well. So for the primary benefit of using probability sampling methods is the ability to make inference. So we can assume that by using simple random sampling, we attain a representative sample of the population. The results can be extended or generalized to the population. If we use a probability sampling method and do the entire let's assume that entire analysis or something like that, do the sampling and everything, then we can make any kind of inferences, or else we can derive our results, so we can results can be extended or generalized. The results which we obtain from those samples can be generalized or else extended for the populations as well. Example 1.1 survey methods. Okay. Can someone explain me? So, can someone explain me the entire scenario? I'll give you 5 minutes. So, please go through with this entire scenario and explain me what has happened here. If any volunteers are here, then they are warmly welcome. If not, then I'll pin out so that those people can answer. So here, example 1.1, it's kind of a survey methods, airline company survey of passengers. So let's say that you are the, can someone explain me the entire scenario, what has happened here? Just read the entire slide by yourself. What we need to do, what are the determinations, how we can do the survey, what are the things we can do. Okay. Any volunteers to describe these survey methods? What we have, what we have in this slide? Can anyone describe? Any volunteers? Okay, Chamudi, can you explain what are the survey methods? Can you explain me this entire scenario which I have mentioned here? Sarani?
This is a scene which represents if we have an airline company and uh, if we want to know about the passengers ideas about our company, whether they are like to travel on our airline or not, and this explains the methods we can use for do a survey kind of thing, madam.
Yes, yes. Yes, that's it. So let's say that you are the owner of a large airline company and you live in Los Angeles. So you want to survey your Los Angeles passengers on what they like and dislike about traveling on your airline. So we just wanted to take few feedbacks. what the passengers think කියලා. So for each of the methods, determine if a non-probability method or a probability method is used. Then determine the type of sampling. Okay, so for the first one, since you live in Los Angeles, you go to the airport and just interview passengers as they approach your ticket counter. So what type of is it is it a probability method or else a non-probability method? Anyone? For the simple A, Sulochana, Sulochana or Sulochana. So for the simple A, first one, that is, are we using a probability method or else a non-probability method? I guess no one is in the class actually.
Non-probability method.
Non-probability method, yes. Non-probability method. And what type of sampling method here they have used? Shilpa or Shilpa? Shilpa. What type of sampling method they have used? For the non-probability method, we had two sampling methods. So one is the convenient one, the other one is I also couldn't remember. One is the convenience one and the other one is the gathering one. So for the first one, is it a convenience one or else a gathering one? Harushi? It's kind of a convenience one, right? Since you live in Los Angeles, you go to the airport and just interview passengers as they approach your ticket counter. No? Yes, අපි එන අයට අපිට පහසුවෙන් කරගන්න පුළුවන් කට්ටියක් නේ. So that it might be like මොනවාද convenience approach. So සමහරක් වෙලාවට let's assume we just put a notice and කියනවා we just need to collect some data if anyone preferred to provide answers, so anyone willing to answer for those questions කියලා කිව්වොත් අන්න එහෙමනම් අපිට පුළුවන් ඒක gathering එකක් විදිහට consider කරන්න. එතකොට මොකද වෙන්නේ? කැමති අය තමයි ඒ research ඒ questionnaire එකට response කරන්නේ. Likewise, you can check these 5 scenarios and check whether these are having probability methods or else non-probability methods කියලා. Okay, that's it. So here we have the answers as well. Non-probability methods, convenient sampling. For the next one, likewise, I have already given you the answers as well. So, okay. And also for this one, this is kind of a question in predicting the 2008 Iowa caucus results. A phone survey said that Hillary Clinton would win, but instead Obama won. Where did they go wrong? So the survey was based on landline phones, which was skewed to older people who tended to support Hillary. If you could find out few newspapers on those days, it was like ගොඩක් කතා වෙන topic එකක් වුණා මේ මාතෘකාව ඇයි ඒගොල්ලොන්ගේ prediction එක වැරදුනේ කියලා. So however, lots of younger people got involved in this election and voted for Obama. So the younger people could only be reached by the cell phone. Okay, this was kind of a scenario or else actual thing what happened earlier. Now let's move to the types of studies. Okay, so when it comes to, okay, is it clear up to this point? I hope it's clear. So let's move from here. So types of studies. Now that we know how to collect data, the next, so up to this point, we just know how to collect data, how to sample, uh, how can we define the population and what are the population parameters, what are the sample statistics. We know everything, how to collect data, how to sample data, and also what are the sampling methods we have. So under those two separate sampling methods, what we have actually. So those are kind of few things which we talked so far. Now that we know how to collect data, the next step is to determine the type of study. The type of study will determine what type of relationship we can conclude. There are predominantly two different types of studies. One is observational study and the other one is experimental study. One is the observational study and the other one is the experimental study. What are the differences of these two? Observational study and the experimental study. Observational study means it's actually a study where a researcher records or observes the observations or measurements without manipulating any variables. එයා මුකුත් variables මුකුත් consider කරන්නේ නැහැ. He or she just observe those variables and get. These studies show that there may be a relationship but not necessarily a cause and effect relationship. මොකද අපි at a glance අපි බලලානේ කරන්නේ. Observational one. But for the experimental one, a study that involves some random assignments of a treatment, researchers can draw cause and effect or causal conclusions. An experimental study may also be called scientific study or an experiment. අර අපි ඉස්සර පොඩි කාලේ කියන්නේ පාලක පරීක්ෂණ කියලා. So these are kind of experimental studies. But for the observational means අපි check කරලා check කරනවා කියලා කියන අපි නිකන් නිරීක්ෂණය කරලා බලලා මොන හරි inference එකක් derive කරනවා. හැබැයි ඒක maybe a relationship මොන හරි තියෙන සම්බන්ධතාවයක් වෙන්න පුළුවන්. හැබැයි ඒක ඇත්තටම තියෙනවමයි කියලා we can't say. ඒ කියන්නේ ඒකමයි හරියටම හේතුව cause and effect එක ඒ relationship එකට කියලා we can't say like that. But for the experimental one, yes, if we do an experimental one, that's totally fine. A study that involves some random assignments on a treatment, researchers can draw cause and effects. From the experimental one, yes, that's totally fine because we have already draw an experiment. Okay, so that is it. Note, random selection. A probability method of sampling is not random assignment as in an experiment. In an ideal world, you would have a completely randomized experiment, one that incorporates random sampling and random assignment. Example 1 to 2. Types of studies. So what are the examples? Quiz and exams course studies. Let's say that there is an option to take quizzes throughout this class. In an observational study, we may find that better students tend to take the quizzes and do better on exams. Consequently, we might conclude that may be a relationship between quizzes and exam scores. But let's assume that we had an experimental study. In an experimental study, we would randomly assign quizzes to specific students. අර හොඳට perform කරන අයටම දෙනවා කියලා එකක් නැහැ. අපි randomly assign කරනවා හැමෝටම. හැමෝටම හරි specific students ලට. We do it randomly. to look for improvements. In other words, we would look to see whether taking quizzes, courses, higher exam scores as well. That's it. Okay. Okay. So let's move to this part. So, causation. It is very important to distinguish between observational and experimental studies, since one has to be very skeptical about drawing cause and effect conclusions using observational studies. The use of random assignment of treatments, that is what distinguishes an experimental study from an observational study, allows one to employ cause and effect conclusions as well. Ethics is an important aspect of experimental design to keep in mind. For example, the original relationship between smoking and lung cancer was based on an observational study and not an assignment of smoking behavior. මොකද ඒ වගේව සමහරක් වෙලාවට අපිට observation එකකින් මොනවාද experimental එකකින් කරන්න බෑ. මොකද ඒකට හේතුව එහෙමනම් අපිට මිනිස්සුන්ව පොළඹවන්න වෙනවා smoke කරන්න කියලා. So we can't do that. So those kind of experiments or those kind of research or those kind of studies comes under this observational research or else observational studies. Is it clear up to this point? So here I have mentioned, like, we want to decide whether Advil or Tylenol is more effective in reducing fever. Here I have mentioned two type of methods. So what would be the solution, Kiela? I just wanted to derive. So here, anyway, for the method 1, also I have provided a solution, and method 2 also I have provided a solution. So you also may sometimes given these kind of questions, these kind of questions during the exams, practical questions actually during the written paper as well, so that you have to provide kind of subjective questions. එක්කෙනෙක්ගෙන් එක්කෙනෙක්ට question එක වෙනස් වෙනවා. Answers ඔක්කොම වෙනස් වෙනවා. තමන් හිතන විදිහට තමයි කරන්න වෙන්නේ. Okay? That's about it. Any questions? Okay, so let's move to the variables. Before that, can someone confirm me whether you all can kind of clear up to this point, Kiela? No one. Okay, so if we talk about variables here, there are kind of, what are the variables? So when it comes to variables, a variable is any characteristic, number or quantity that can be measured, counted or observed for records as well. So there are two types of variables. One is the response variable, the other one is the explanatory variable. What is the response variable? Variable that about which the researcher is posing the question may also be called the outcome or the dependent variable. Response variable එක කියලා කියන්නේ generally the value y. Dependent variable. අපේ output එක. But for the explanatory variable, that means variables that serve to explain changes in the response, they may also be called the predictor or else the independent variable. So explanatory variable, that means the independent variables. Another name is for the explanatory variable, that is independent variable or else the predictor. And for the response variable, that is the outcome, or else we can say it as dependent variable. So here a special note is there. A variable can serve as an explanatory variable in one study, but response in another study. එක variable එක study එකක සමහරක් වෙලාවට explanatory variable එකක් තිබුණට තව එකක response variable එකක් විදිහට ඒ variable එකම consider වෙන්න පුළුවන්. අපිට කියන්න බෑ හැම වෙලාවෙම හැම study එකකම එකම variable එක response variable එක විදිහටත් explanatory එහෙම නැත්නම් explanatory variable එකක් විදිහටත් use කරනවා කියලා සමහරක් එකක input එකක් වෙන එක සමහරක් එකක output එකක් වෙන එක අනිත් research එකක එහෙම නැත්නම් අනිත් study එකක input එකක් වෙන්න පුළුවන්. That's about it. And then example 3 from the first lesson, that is response and explanatory variable. So here consider the variables sex, that is female and male, and height, which is in measured in inches. Which variable do you believe explains the other? In other words, would it make more sense to say a person's sex more likely explain that person's height, or to say person's height explains that person's sex? What do you think? සෙක්ස් එකත් එක්ක හයිට් එක එක්ස්ප්ලේන් කරනවා කියලා කියන්නද නැත්නම් ඒ කියන්නේ ජෙන්ඩර් එකෙන් හයිට් එක එක්ස්ප්ලේන් කරනවා කියලා කියනවද නැත්නම් හයිට් එකෙන් ජෙන්ඩර් එක එක්ස්ප්ලේන් කරනවා කියලා කියනවද? What would be මොකක් එක්ස්ප්ලේන් කරනවා ඇතිද? What do you think? So actually, in this first scenario, in this case, sex would explain height, making sex the explanatory variable. අපි input එකක් විදිහට explanatory variable එකක් විදිහට sex එක දුන්නොත් ඒකෙන් අපි බලනවා අර අපි බලන්නේ female අයගේ height එක කොහොමද, mean එක කොහොමද, height mean එක කොහොමද ඒ වගේ. එතකොට sex එකට අනුව difference එක බලනවා height එකේ. එහෙනම් output value එක විදිහට consider කරන්න වෙන්නේ response variable එක විදිහට consider කරන්න වෙන්නේ height එක, and the input value or else the independent value would be the explanatory variable, that is sex. For the second one, consider the variable height and weight, which is the response, which is the explanatory. Height and weight එක ගත්තොත්, in this case a person's height would more likely to explain their weight. ගොඩක් වෙලාවට උසින් ගොඩක් වෙලාවට weight එක කියනවා වෙන්න පුළුවන් than the other way round. So එතකොට person's height would more likely to explain their weight than the other way. එහෙනම් weight එක කියලා කියන්නේ y value එක, that is the output value. For the input value or else the independent value, we have the මොනවද ඒවට කියන්නේ height. Is it clear? And also we have another two variables as well. One is other types of variables includes lurking variables as well as the confounding variables. What are the differences of these two? The lurking variable as well as the confounding variable. Just read this slide and let me know the difference of these two variables. What do you think? What are the differences of these two? So here for the other variables, other types of variables, we have two different variables. One is the lurking variable and the other one is the confounding variable. For the lurking variable, a variable that is neither the explanatory variable nor the response variable but has a relationship. That means actually a variable that is neither the explanatory variable nor the response variable but has a relationship, for example, may be correlated with the response and the explanatory variable. අර දෙකත් එක්කම correlate වෙනවා. එක ළඟ යනවා. It is not considered in the study but could influence the relationship between the variables in the study. සමහරක් වෙලාවට අපි අපේ study එකට මේ variable එක consider කරන්නේ නැතුව වෙන්න පුළුවන්. But anyway, the main input and the output variables might be affected or else might be influenced by these lurking variables as well. That is the lurking variables. And for the confounding variable, a variable that is in the study and is related to the other study variables, thus having an effect on the relationship between these variables. So a lurking variable, if needed in the study, could have a confounding effect and then be classified as a confounding variable as well. So the confounding variable means a variable that is in the study and is related to the other study variables as well, thus having an effect on a relationship between these variables. Maybe okay, that's it. So a lurking variable, if included in the study, could have a confounding effect and then be classified as a confounding variable as well. That is it. So here I have given another example for the lurking variable as well as the confounding variable. Hope you can read this one and identify what are the lurking variables and also the what are the lurking variables and also the confounding variables. If you have any questions, you can ask me from next day. Otherwise, the answer also provided within this lecture note itself. Then let's move to the principles of experimental design. Okay, now what we do here is just don't think that too much of theories and on something like that, because anyway, if you are now anyway you have to conduct your researches as well, no? So for those ones, these are like practical things which you have to apply while when you are doing your research. So these ones, so no need to recall and memorize, no need to by heart, but just memorize these things. It will help you to do your research very easily. So the principles of experimental design, the following principles of experimental design have to be followed to enable a researcher to conclude that differences in the results of an experiment not reasonably attribute to chance are likely caused by the treatments as well. There are three types of experimental designs. One is a control experiment. The other one is the randomization. The final one would be the replication. For the control one, you know, right? අර පාලක පරීක්ෂණ කියලා කියන්නේ කොටසක් අපි control කළා. එකක් අපි control කරනවා අනිත් එකට අපි ඔක්කොම දෙනවා. So for the control experimental design, need to control for effects due to factors other than the ones of primary interest. And for the randomizations, here subjects should be randomly divided into groups to avoid unintentional selection bias in the groups. So for the replication, a sufficient number of subjects should be used to ensure that randomization creates groups and resemble each other closely and to increase the chances to detecting differences among the treatments when such differences actually exist. That is the replication part. Anyway, we are doing it again and again. For the randomization one, subjects should be randomly divided into groups to avoid unintentional selection bias in the groups. For the control one, it's basically we controlled few factors on a we controlled for effects due to factors other than the ones of primary interest. අපි primary එක විදිහට අර අපි මොනවාද ඉස්සර පොඩි කාලේ කරන්නේ පාලක පරීක්ෂණය වගේ එක දෙයක් මොකක් හරි තියලා අනිත් ඒවා ඔක්කොම control කරනවා. Likewise අනිත් ඒවා එක්ක ඔක්කොම එකම විදිහට දීලා එකක් විතරක් control කරනවා. These are the three different principles of experimental designs. So here I have mentioned the benefits to randomizations also. You can read these ones. If a random assignment of treatment is done when the significant results can be concluded as causal or cause and effect conclusions, that is, that the treatment caused the result. So this treatment can be referred to as the explanatory variable and the results is as response variable. So the results would be the y value and the input value would be the treatment. If it is treatment caused experiment or a result. Okay. So if random selection is done where the subjects are randomly selected from some population, then the results can be extended to that population. So the random assignment is required for an experiment when both random assignment and selections are part of the study. Then we have a completely randomized experiment that is without random assignment. That is an observational study. Then the treatment can only be referred to as being related to the outcome as well. That is it. Sorry. Okay. So can someone confirm me whether you all can understand? I mean, it's kind of a clear up to this point. Can anyone reply me on the chat itself, please? What do you think? Can manageable or what do you think? Any idea?
Excuse me, madam.
Yes.
Yeah, madam. So these are like kind of new to me, and so therefore it kind of feels heavy. I don't know about the others. Like I don't have a background to this, so
Okay, so that means you so anyway I'll upload the entire slide set within today itself to the LMS. You can go through with these entire slides and if you have any questions anyway you can ask from me. So in which department are you from?
I'm from English department, madam.
English department, yes. If you go through with this entire slide set, I'm so sure that you all can understand these ones. Don't worry, if you have any questions, come to me so that I can help you.
Yeah, sure, madam. It would be better if you can like upload the recording as well.
Yeah, sure. I'll upload it. Within
Okay.
today, I'll upload it.
Okay, madam. Thank you.
Okay, no problem. Any other feedbacks? Any other ideas or any other feedback? What about others? Yes, madam. Okay. Yes, madam, in the sense, that means it's clear for few, right? It's clear for few, which, okay, once we are, since we are new to this, it's quite difficult, but I think we will manage, madam. Yes, obvious. Okay. Then let's continue. So classifying data. Now, when it comes to then we are going to talk about classifying data. So this is kind of distinguishing between the different types of variables is a basic and integral part of applied statistics. So the methods to analyze these data are very different, and therefore it is important to make the distinction. The two types of variables are qualitative and also the quantitative. That means mainly we have two types of variables. One is qualitative variable and the other one is the quantitative variable. When it comes to qualitative variable, that is categorical variable. Another name for the qualitative variable is categorical variable. And for the quantitative variable, that is again, we have the numerical variable. Okay. So if we go through with these qualitative variables or else the categorical variable, again, we have kind of few, what would be those, we would say like measurements. Okay. For the categorical variable also, mainly we have only two measurements actually, that is ordinal and also the nominal. And also we can say another measurement as binary as well. So if it is, if we go through with this ordinal and nominal, that is basically what nominal in the sense that the female, male, there's nothing, I mean, there is no any order to concern. But for the ordinal categorical variables, that is sizes of a cloth, මොනාද ඒවට කියන්නේ extra small, medium, large and extra large. That is comes under the ordinal. Though it is categorical variable, we have an order. Is it clear the difference of the ordinal and as well as the nominal? So ordinal is where the names imply levels with hierarchy or order of preference. For example, level of education or else the size of a cloth, etc. So for the nominal one, what would nominal one, there is no any hierarchy or there is no any order to concern. For example, political party affiliation. That is kind of an example. And for the goodma one, hondama eka, what would be that the nominal one would be like a gender. Okay, gender is the best way, female and male. And for the binary, there might be binary variables as well. That is not an important category here, measurement here. Anyway, for the, if we call binaries, then where there are two choices, yes, no, male, female. Okay, likewise. So for example, for coding purposes, you may assign male as 0 and female as 1. So the numbers 0 and 1 stand only for the two categories and there is no order between them as well. And for the quantitative variables, that is numerical variables. So data that takes on numerical values that has a measure of distance between them. Quantitative values can be anyway discrete or else continuous. Discrete or else counted, and for the continuous or else measured. Discrete means it's actually for example, we can say the number of people in attendance. අපිට count කරන්න පුළුවන් 1 2 3 4 5 6 කියලා. That is discrete. But for the continuous one, for example, weight and height. අපිට එක්කෙනෙක්ගේ weight එක we can say 50 kilograms. That is 50.0. But for another person's, for another weight of person, තව පුද්ගලයෙක්ගේ මොකක් හරි weight එකක් අපි කියනවා 49.123. From you by using the 3 decimal places. So those kind of measures, we called them as continuous measures. But for the countable one, 1 2 3 කියලා අපිට count කරන්න පුළුවන් ඒවා, we generally called it as discrete. Any questions? So additional examples of both includes, here I have given the quantitative and discrete one, categorical and nominal one, quantitative and continuous, and also a categorical binary example as well. Then summarizing one qualitative variable. Okay. We have another 20 to 25 minutes, so that I'll continue. If it is kind of too much now, okay, anyway, I'll put the recording now so that you can go through with this. So for the summarizing one qualitative variable, once we determine that a variable is qualitative or else the categorical, we need tools to summarize the data. So we can summarize the data by using frequencies and by graphing the data as well. Let's start by an example. In a class size of 30 students, a survey question asks the students to indicate their eye color. The responses are shown in the table. These are the responses which they are given. From this list itself, we can clearly say that the eye color brown is the most common answer which we have found, which is more frequent hazel or green. It may only take a few seconds to answer the question, but what if there were? So here we have only 30 students, so that we can say what would be the most most frequently used eye pattern eye color we can say. But let's assume that we have the outputs, or else we have the responses of 100 students or 1,000 students. So can we derive such kind of a conclusion by using this table itself? Can't, right? So if it is 100 or thousands data, now we can't say it at a glance, no. So anyway, then we have to analyze by using any chart or something like that, and then provide that final solution. That is it. Okay, so then we have the proportion and everything. So a proportion is a fraction or part of the total that possesses a certain characteristic. The best way to summarize the categorical data is to use frequencies and percentages like in the table. I hope you may have sometimes used for these categorical variables. Anyway, if you have already used Excel as well, we just draw percentage, the pie charts and everything for the categorical variable representations. Eye color, brown, blue, hazel, and green. So the frequencies of those ones and the percentages are here. That's it. So the table is much easier to read than the actual data. It is clear to see that more students have hazel than green eyes in the class. As the saying goes, a picture is worth 1,000 words. It is helpful to visualize the data in a graph. So anyway, rather than kind of deriving those kind of answers, it's better if we can draw a table like this and provide the answers. That is it. Okay. So then graphing one qualitative variable. So okay, these are kind of few graphs, few graphs which we can use to draw, which we can use to describe the qualitative variables actually. So the pie charts and bar charts, these are kind of few charts which we use to explain, or else which we use to explain qualitative variables so that you can draw these charts by using the Minitab or else SPSS or any kind of tool as well. So we'll do these practicals in next day. So again here the Minitab graphing one qualitative variable, here I have mentioned the steps as well so that you can try it one. So the solution would be like this. Summarizing one qualitative variable, again will it be okay, that is it. So here what will happen, we will first talk about descriptive measures of quantitative data. The most important characteristics of a data set, central tendency will be given, so that after that, okay, I hope from this part onwards, let's discuss summary measures and everything. No, so it's better if we can discuss these topics from next day onwards. So if you have any questions, you can ask from me. Otherwise, we can wrap it up for today, and let's meet up next day. If you don't have any questions, then we can wrap it up the session. So thank you so much for joining the session. See you on next week physically. Thank you so much.